stream of outdoor air is mixed with a stream of return air in an air conditioning system that operated at 101.325 ppa barometric pressure. The flow rate of outdoor air is 2.0 kg per second, and the condition is 35 degrees Celsius dry bulb and 24 degrees wet bulb temperatures. The flow rate of the return air is 3.0 kg per second, and its condition is 24 degrees Celsius dry bulb and 50% RH. So we have the questions: determine the enthalpy of the mixture, the humidity ratio of mixture, and the dryable temperature of the mixture. And D, we have if the total partial pressure is 98 kPa absolute. Solve the same requirement. So if you're going to draw it in a schematic diagram, so this will be looking like, so we have the supply from your M2 and for your return, so usually 3 kg per second dry bulb, 24 RH50. Then we have your outdoor, which is 2 kg dry 2 kg flow rate. Then we have your dry bulb 35 and your wet bulb 25 degrees. Pero pwede natin siyang i-represent plus, no? It can be represented as like this. So usually class, if this is the para magkaroon kayo ng idea, no, bakit nangyayari yan. So if we have, this is the space, no. Okay. So you will be supplying here your supply duct, this one. This is your supply duct, no. Then we have here your FCU. So FCU, so that stands for fan coil unit. Then you have the duct here from the fresh air, so that is outside the building. So usually ganyan yun siya. So this is your point 1. So the properties goes here, no? Now yung properties ng point 2, so let's try to erase this one para pakita that is the space. Okay. Then for the property, in order to have a recirculated air, is we take portions of duct here. We draw portions of duct here. Yeah. And let's try to erase this one and this one. Now the properties ng point 2, that will be yung 3 kilograms dryable 24 is this point, no, entering. So this will be your point 2, or pwede rin naman dito, pwede rin naman dyan. So it is a recirculated, so you supply a fresh cold air dito sa space. Then the space usually the space cools, and also the heat is absorbed by the air, so which is yung heat naman are rejected by the occupant and also the person, also the equipment and everything inside the room. Now, so in order na makatipid yung owner, o makatipid ang owner sa load nito, okay, so you need to recirculate yung air doon. So mapapansin nyo that is 24 degrees Celsius na yung temperature niya compared doon sa outside, which is 35. So yung cooling load mo na isusupply is minimal. So when you say it's minimal cooling load, it also yung takbo ng compressor ng air conditioning mo will also be minimal. So it conserves electricity, kumbaga. So it is controlled by a volume control damper. So later on we'll tackle on this one. So this is only controlled by a tinatawag natin na BCD, or that is what we call volume control damper. So later on makikita natin yan. So, ano itsura ng volume control damper, and next lesson will be on the last lesson, that will be on the ventilation. So I will be showing what is the purpose of ano yung itsura ng volume control damper. Okay, so we've been recirculated. This is now your FCU. Now, so yung mixing point na yan, ito na yung point na yun, which is yung point 3. So ito na yung point 3 natin. So this is your point 2, and this is your point 1, and this is your point 3. So in order to this is the representation, actual representation, but it is a schematic diagram lang to show you yung ano. So kasi baka mag-wonder kayo bakit saan to nanggaling ito, sa indoor, outdoor. So this is the actual representation, so that you can have the idea kung ano yung ginagawa at kino-compute natin. Okay. So I'm bringing the psychrometric chart here again. So let's plot the properties first on the psychrometric chart, so that we have the idea, so what will be the enthalpies and the moistures using the psychrometric chart, no? So for the point 1, we have the properties of, so that is 35 degrees Celsius. So plotting here, so you have your line drawing here, so that will be 35. Dry bulb, so let's color it red. Okay. 35 degrees Celsius. Then we have a corresponding 25 degrees Celsius of your wet bulb, no? So we have here this one is 30 wet bulb temperature. So we have now this one. Okay. So this is our point 1. So this is now your point 1. Okay. Then let's also establish the point 2. For the point 2, that will be 24 degrees Celsius, no? 24 degrees dry bulb. 25, this is this one. Ayan. So let's color it red. So this is 24, 25, 24. Then we have 50% RH. So we have this one. So you notice this is the 50% RH relative humidity line. Okay. So we have now your point 2. So let's draw the line. Then hindi pa natin pwede i-draw ang line, no? So since we cannot find the properties of point 3, okay, so at least we can get the other properties para makita natin kung saan yung point 3, saan saan siya saan siya dito magpa-plot, no? So let's plot the moisture here. What will be the moisture content, the humidity of point 2, and also the humidity for your point 1. Okay. Then also we have your enthalpy of point 1. So what will be the enthalpy of point 1? Okay. And the enthalpy of your point 2. What will be the enthalpy at the point 2? Okay. So we have now the properties, so we need to determine. So let's try to write that one. So let's start with the humidity 1. So for the humidity 1, so we have 0.016. So this will be kilogram per kilogram of dry air. Now for the humidity 2, so that will be 0.009. So this is 5, 6, 7, 8, 9. So let's say this is 25 kilogram per kilogram dry air. For the enthalpy at point 2, so we have the properties. Enthalpy at point 2 will be, so this is 45, 46, 47, 48, 49. So you have 50, 45, 46, 47. So it's around 47. 47.5, so we can put it 47.5. So kilojoule per kilogram. So this one. For the enthalpy 1, so we have here 75. Okay, so that will be 76.5 kilojoule per kilogram. Okay. Okay, so from the psychrometric chart, okay class, so palagi nyo i-indicate ito. No? So at point 1, so we have 35 degrees Celsius, dry bulb, then isusulat nyo yung mga values ng enthalpies at humidity. The same also with the point 2. So take note yan palagi. Hanapin ko yan sa design nyo. It should be noted doon kung some point na saan kinuha yung mga properties na yun. Okay. So question number 1. So what will be the enthalpy of mixture? So we can rewrite the equation, the energy, the mass balance, so energy and also energy balance. We have your enthalpy 1, mass 1 and enthalpy 1 plus the mass 2, enthalpy 2, which is equal to mass 3. Then you have your enthalpy 3. So where our enthalpy ay mass 3 is equal to mass 1 plus the mass 3. So this is mass 2. Then we can rewrite our equation to get the enthalpy as your mass of 1, enthalpy 1 plus the mass of 2, enthalpy 2 divided by the mass 1 plus the mass 2, which is already also given. Now let's substitute the values. So we have your mass 1. So substituting the values, so we have your mass 1 is 2.0 kilogram per second. Then we have your properties of your enthalpy 1, which is 76.5. So we have 76.5 kilojoule per kilogram. Then plus the mass 2, properties of mass 2, that will be 3.0 kilogram per second. Then it will be multiplied by the enthalpy 2, the properties of enthalpy 2, that is 47.5. It is 47.5 kilojoule per kilogram. Then divided by 2.0 kilogram per second plus 3.0 kilogram per second. So cancel out, which is yung common. So kilograms per second. Then finally we have the enthalpy at this point. So we have 59.1. So this will be kilojoule per kilogram. So if we're going to plot this one, hanapin natin siya sa psychrometric. So it is somewhere lying here. So this is 55, this is 59. Okay, so the line will be at this point 65, and it is 59.1. So this is 59. So somewhere, so let's use a line. Okay. Now, ang tanong, saan ba yun banda? So, pwede siya mag-urong pa doon sa loob or urong pa doon sa labas. So, hindi pa natin malaman kung saan siya banda. So, this is now your 59.1. So, we have your enthalpy 3, which is 59.1 kilojoule per kilogram. Okay, so, yan. So, hindi pa natin ngayon malaman kung saan siya magbubunggo doon sa mga curves. So, let's solve other properties. So, let's try to solve the humidity mixture. So, knowingly, the energy balance or the mass balance, we have this equation. So, it's very easy na lang to solve the values of other properties of humidity. So, we can rewrite now our equation. So, para madali lang siya. So, it's very easy. Madali lang naman siyang solve, no? Hindi naman totally complicated. Okay. So let's substitute yung values in order to get the humidity at point 2. So we have now 2.0 mass 1. So we'll remove na point n. So 2 kilogram per second. It will be multiplied by the values of humidity 1. So values of humidity 1, that will be 0.016. 0.016, that will be kilogram per kilogram dry air. Then plus 0.2, that will be 3 kilogram per second. Then it will be multiplied to the humidity at 0.2, which is 0.00925. That is 0.00925. So that will be kilogram per kilogram dry air, then divided by the values of 2 kilogram per second plus 3 kilogram per second. Okay, so cancel out yung common units. We have, this will be cancelled out. Then we have the values of your humidity, which is equal to, using your calculator. So we have 0.01195. Or let's say this is 0.012. So that will be the humidity per kilogram of dry air. So it will be the humidity ratio. So let's multiply it by, so since it is grams, multiply by 1000. So we have the value of 11.95. So this will be grams per kilogram dry air. Okay. So 11.95. Sorry, this is already 12 na pala. So this will be 12. Sorry. So we'll change it to 12 na since we run off na rin pala yun. Okay. Sorry for that one. This will be 12 grams. So plotting in the curve. So we have your humidity here. So this is now 15, this is 10, 11, and 12. So we have here 12. Humidity 3, that will be 12. No? So this will be grams per kg of dry air. Since the nakalagay dito, that will be grams of moisture per kilograms of dry air. Okay. So from here, we can plot. Dito pa lang, makikita na natin class yung sana intersection niya. If you get already the humidity, so we can get now the values ng kanyang intersection. Yeah. So we have now the intersection here of the humidity. So intersecting at this point. So this is now our point 3. Okay. So to confirm, we can also do another temperature balance. So the temperature to confirm. So solving for the temperature of the mixture. So again, we have your equation. That will be dry bulb 1 plus the mass 2. Then we have dry bulb 2, which is equal to mass 3. We have the dry bulb 3. So we can get your dry bulb 3. So equating that one, dry bulb 1, mass 2, then we have the dry bulb 2, divided by the mass 3, which is equal to your mass 1 plus the mass 2. So dry bulb 3 is equal now to, let's substitute the value. So mass 1, we have 2 kilogram per second, multiplied by the dry bulb 1, which is 35 degrees Celsius, plus the mass 2, we have 3 kilogram per second, multiplied by the dry bulb 2, which is 24 degrees Celsius, then divided by 2 kg per second, plus 3 kg per second. So we can get the dry bulb temperature is equal to, so cancel ang common units. Okay. So we have 28.4 degrees Celsius. Plotting that one, this is 28. So we have the, let's draw the line here. No? Okay. So ito yun. Okay, so we have now, which is, ilan yan? This is 28, no? The 5, 26, 27, 28. So you see, it's the same also na nakuha natin. So we can also use a psychrometric chart to get the value, or we can also do mass balance. But maganda rin mass balance kayo in terms of temperature, just to check, no? So we have to check kung tama ba yung ano niya, yung nakuha natin na value. So your dry bulb temperature is at 0.3, which is 28.4 degrees Celsius. Okay. So let's draw now the process. So draw the line. Since ito mag-limit sila, so we draw the line here. Okay. So dyan nagpa-flow. So the air enters and mix it in the 0.3, and also yung 0.2 mixes also at 0.3. Okay. that solves the problem natin ng values. So, madali lang naman siya. It's not very complicated, no? Okay, so, next with letter D, considering for the total partial pressure of 98 kPa. Okay, so this time we have different situations since yung psychrometric chart natin, no? So, yung psychrometric chart natin is only on the barometric pressure, which is yung atmospheric, which is 101.325 kPa. So, this time, it is in a different low pressure, no? Okay, so, we'll be using the equation, so from the IHB, Institute of Heating, Ventilating Engineers. So, to get the, we call that for the value of your wet bulb, okay, so we'll be using this equation. So for wet bulb temperature is equal to or greater than 0, so we can use this one. So pag less than, so it is where in greater than 0, so we can use this equation to get the value of your wet bulb, to get the partial pressure. Then in order for us to get your wet bulb, to get the humidity ratio, sorry. And also we'll be needing this one to get the humidity, and this equation. Then also the enthalpies to get these values of also. Okay. Okay, so we have your wet bulb at 25 degrees Celsius now. So we have, I'm bringing down here the saturated temperature table for the from the steam table. So we have your wet bulb. So at the wet bulb 1, which is 25 degrees Celsius. 25 degrees Celsius. So from the steam table, so from the steam table at 25 degrees Celsius, we have the corresponding pressure of the wet bulb 1, which is 3.1698. So that is in the unit of kPa. Okay. Then we can solve now the value. Since your wet bulb pressure is given now, then we have the total partial pressure, which is 98. Then we have your dry bulb and your wet bulb. So we can solve the total partial pressure vapor. So we have your PB, that is equal to pressure at wet bulb, that is 3.1698. That will be in kPa. So minus, that will be 6.66 times 10 to the power of negative 4 multiplied by total partial pressure, which is 98 kPa. Then multiply by the change in temperature, which is your dry bulb is 35 degrees Celsius minus 25 degrees Celsius. So this is an empirical formula, no? So no need to cancel out the units. So we have the partial pressure vapor is equal to, so let's close this one. So we have the partial pressure vapor, which is 2.52, okay, kPa absolute. So we can get also the value of humidity 1, no, by using this equation. So substituting the values, so what we have is 0.622. Then we're going to multiply by partial pressure vapor, which is 2.52 kPa absolute. Then we have the total partial pressure, which is 98 kPa absolute minus 2.52 ppa absolute. So we can get the humidity at 0.1 humidity ratio. So what we have now is that will be 0.0164. So this is now kilogram per kilogram of dry air. So we have the value of humidity 1. For solving the enthalpy, so using the equation of IHB, International Heating Utility Engineers, so we can substitute the values now to get the values of enthalpy at 0.1. So enthalpy at 0.1, that will be 1.007, then multiply by the temperature, so which is 35 degrees Celsius minus 0.026, then plus your humidity 1, which is 0.0164, that will be kilogram per kilogram of dry air. Okay. Then will be multiplied to 2501 plus 1.84, then it will be multiplied by the temperature, which is 35 also. Okay, so just bracket this one, another bracket dito. Then we have finally the value of your enthalpy. So we have 77.29. So this will be kilojoule per kilogram of dry air. So at the point 2, so we have to get the 24. Take note, we're using now here the dry bulb, no? Since we do not have walang binigay sa problem na wet bulb temperature ng 0.2. So compare nung kanina, so which is yung 25 degrees, that is wet bulb. Now in order to get the saturation pressure, so let's first determine what will be the saturation pressure of 25 degrees Celsius, then we'll get the saturation pressure or partial pressure vapor multiplied by the relative humidity para makuha natin yung pressure niya ng saturation. Now looking at the psychrometry at the steam table, so you will notice here we are in between 20 and 25, so we can do interpolating. So we have your 20 degrees Celsius natin yung units, so 20, so we have the value of so that will be 24 and 25, so we have the value of 2.3392, so you have your x, which is unknown, so we have 3.1698. okay, so we do interpolating nito para makuha natin yung which is yung pagitan 24, so it will be 20 minus 25, which is equal to 2.3392, which is minus x divided by 2.3392 minus 3.1698. So simplifying, we have these values. So, meron tayo dito na sa kabila, which is 0.85. Dito, 2.3392 minus x. Then, sa ilalim, we have negative 0.8306. So, cross multiply. So, we have 0.85 times negative 0.8306. We have 2.3392 minus your x, so transpose, so we have the value of x will be 2.3392, so this will be negative, no? So that will be times 0.85, So it will be positive plus 0.70601. So we have 2.33. So we have 3.045 kPa absolute. Okay, so 3.045. So checking. So in between, so makikita nyo naman na nasa gitna pa rin yung values natin. So I think it's very good to go. Tama naman siguro, tama yung calculation natin. So we're in between. So we have now your equation, no, for the relative humidity. So your RH, which is yung RH natin is 50%, no? So from our equation, given the problem, so the RH is 50%, is equal to 50%. So to get the partial pressure, so we're just going to derive this one. So that will be your RH multiplied by the PD, so that will be the saturation pressure. So take note, the definition, saturation pressure of water vapor at the given dry bulb. Since we have a given dry bulb, so we can get the partial pressure of water vapor at given dry bulb. Okay, so that's one way that we to determine the value. So since we have now the partial pressure of vapor, so it will be multiplied by 0.5 since we have around 50%. Then we have your 3.045, so that will be kPa absolute. So we have now the partial pressure of vapor at the given dry bulb temperature. So we have 1.5225, so kPa absolute, so that will be the partial pressure of vapor. So solving for the humidity ratio at 0.2, so we'll be using the equation, this one 0.0, this is 622, that will be multiplied to partial pressure of vapor at 0.2, so this is now 2. Then we have total partial pressure minus the partial pressure of vapor at 0.2. So we have the humidity, that will be 0.622, then multiply by 1.5225 kPa absolute divided by total partial pressure, which is 98 kPa absolute, minus 1.5225, so that will be kPa absolute. So we have the humidity at 0.2. So we have the value of 0.0098, so that will be kilogram per kilogram of dry air. Now using this equation from IHBE, Institute of Heating Ventilating Engineers, so we have the enthalpy at enthalpy at 0.2 will be 1.007 times the temperature we have, that is 24 degrees Celsius, minus 0.026 plus the humidity that we have. So that is how much? That is 0.00, that is 0.0098 kilogram per kilogram of dry air. Then multiply it to 2501 plus 1.84 times 24. Okay, so we have the value of enthalpy at 0.2. So we have the value of enthalpy at 0.2, that is equal to 49.08, so kilojoule per kilogram of dry air. So now solving for the enthalpy of the moisture, so we can use the equation also that we used nung kanina. So what we have there, so we can plug that one, so this one. So ito, we can use also this, we'll be using this equation. So to get the value of enthalpy 3, so we have, so that will be your mass 1, that will be 2 kilogram per second, that will be multiplied by your enthalpy 1. So yung enthalpy 1 natin, nakuha natin kanina, so that is so we have your enthalpy 2, which is 49.08 kilojoule per kilogram dry air. Then it will be divided by 2 kilogram per second plus 3 kilogram per second. So we have now your enthalpy 3. So we have now enthalpy 3, which is 60.36 kilojoule per kilogram. Now solving for the humidity of the mixture, so we're using again yung equation kanina for the moisture. So we have mass 1, humidity 1 plus the mass 2, humidity 2 divided by the mass 1 plus the mass 2. So we have 2 kilogram per second, then multiply with the value of humidity 1, so that will be 0.0164 kilogram per kilogram of dry air, kilogram of moisture per kilogram of dry air, plus the moisture 2, 0.0164. So we have 0.0098. So this will be 2 kilogram per second, 0.00. That is 30, 2 zeros na, 98 kilogram per kilogram dry air, then divided by 2 kilogram per second. We need to close parenthesis that one, that will be plus 3 kilogram per second. So cancel out ang common units that we have. Then finally we have the value of your humidity 3 using your calculator. So we have the value of 0.01224 kilogram of moisture per kilogram of dry air, humidity ratio. So solving now for the dryable temperature of the mixture, again using the equation. So kanina yung ginamit din natin. So it will be dry bulb 3 is equal to the enthalpy 1, dry bulb 1 plus mass flow rate 2, you have the dry bulb 2, then we have mass 1 plus your mass 2 is equal to your mass 1, that will be 2 kilogram per second. Then you have the dry bulb, which is 35 plus we have your 3 kilogram per second, then multiply it by 24 degrees Celsius, then divided by 2 kilogram per second plus 3 kilogram per second. We have the value so we have the value of 28. Parang wala rin ito nagbago, so wala naman nagbago sa dry bulb natin. So let's check nga, tingin ko wala, may walang changes, tingin ko lang. So we have so it's the same. Okay, so madali lang naman siya. So mostly it is in the direct substitution. Okay. So everybody can